And then I would like to say welcome to Dr. Luis Fernando Lavado Villa from France with the presentation of wind empowerment and open source power electronics, and which means creating a fully bottom-up technology suit for rural electrification. Well, welcome, Dr. Luis Villa, and please go on.
Thank you very much. I'm going to share my screen with you. If I can find, I'll share the desktop. Okay. Hope you guys can see my presentation. Yes, wonderful. First, I'd like to thank you for inviting us, the Wind Empowerment Association, to be part of this conference. We're really very grateful of your invitation. I'm sorry for showing up. I don't know if I'm a little bit late. I was giving a course just before I came here, so I had to kind of run on my bicycle, pedal very fast to get home on time. I'm going to talk to you today about Wind Empowerment, which is our association, and open source power electronics. Now, there is one thing that I think it's very important. I'll start my wind CV. So I'm a young associate professor on electrical engineering at the University of Toulouse. I've been a researcher on power electronics for bottom-up electrification at the last CNRS. It's a laboratory of the National Research Council. I'm an active member of Wind Empowerment, and I built about 15 wind turbines, small wind, on my life, and I've been working on open source power electronics since 2014. I'll start with a summary. I'll start with a big disclaimer, then I'll talk about the Piggott Turbine, I'll talk about wind empowerment, about our global market assessment for small wind, and some technological developments on open source power electronics. Everything up to the global market assessment, it's really collective wind empowerment work. I'll give you the references on it. The last point is my work that I've been doing on the past few years. I've got to charge my computer. So I'll start with the disclaimer. I think this is very important. You guys are in the industry. A lot of you would probably see me as what our colleague just said before, like a snake oil seller who's talking about locally manufactured. And I think this is a very important point that should be said straight up. I'm going to talk to you about locally manufactured wind power. That means what? That means I'm going to talk to you about wind turbines that are built locally by the stakeholders. So we can talk about certification as much as you want, but that's a different topic. That doesn't concern that much as we would like to. It's very important to remember something. We live in a society, developed nations and industrial centers in developing nations. It's a post-industrial society that has chosen a balance between repairable and reliable. When it comes to technology, you have to choose between making something reliable or making something repairable. There's a balance. That doesn't mean you have to be totally on one side or the other. But if you make something reliable, it's usually going to converge to some sort of monolithic design, which is optimized and to allow you to have less downtime, but it has the drawback of having to be closed sourced because you will not have the luxury of actually sharing your technology with other people. It's too expensive to share. You have to have a return over capital. Your only chip of bargain is the technology. And so you close it, you try to have some access to the market, some exclusivity and so on.
Dr. Villa,
yes.
Please speak louder.
Sure. You also have something that is repairable. Repairable means you make things modular. You make things standardized, but you might be looking to more downtime, and you have the big possibility of making things open, because if it needs to be repaired, you got to train people how to repair it. And if you're counting on people repairing it, which are necessarily people from your company, that means even more trusting the knowledge to other people. So there is a balance to be struck between the two. And we live in our society, our industrial point of view is very tilted towards reliable. And I think this is something a lot of the folks I was listening to some of the presentations before kind of touched upon this subject. We have to make things that are so reliable that can go through the high bars that have been established in industry where we live in, that really hurts small wind, because you're taking on all the burden of developing your technology and you cannot really share it with anybody. And that means, in a certain extent, our industrial view is not really adapted to small wind. I'll come back to that on the market assessment. That's where the Piggott turbine comes in. For those of you who don't know, probably the Piggott turbine is a small wind turbine that was developed by Hugh Piggott, who lives in Scotland in the 80s. It's a direct drive axial flux machine. You have an example of the turbine on the right with its split parts, and one 4.2 meter design on the left. These turbines have an indulgent design. That means that they are meant to be locally manufactured. They are way more, even if you make a few mistakes with them during the manufacturing process, they're still going to deliver the power that we're looking into for them to deliver. And so it's a locally manufactured technology. Wind Empowerment is an international association of people who actually use that technology and promote it around the world. We have been gathering together. We started in 2011. Our past 3 conferences are up here. We had one in 2014, one in 2016, and one in 2018. We are currently having our online conference now. There was half of it was last weekend. The other half is next weekend. So I call upon you to, if you're interested into locally manufactured technology, you can take up a look at our website, sign up to the conference and participate. Market assessment talks is next week for those who are interested. It's free, you can join. Wind Empowerment structure is, you have a board of trustees. We are an incorporated charity in the UK. We have an executive board. All of it is international, and we have working groups, 6 working groups, 3 technical, 3 socioeconomical. We have technology maintenance and measurement on technical, and delivery models, market assessment, and education on socioeconomical. If we have an overview of the kind of system that we build, or some of our members build, is you have an axial flux 3-phase Piggott machine, a rectifier, straight into a battery, a charge control, and inverter, and that goes into a household. As a typical system, and the data logger in the middle. So the technology working group has been working on some of those technological pieces. We do have, this is some of my work on the left, is a multifunction power converter, I'll detail later. We've been working on open source charge controllers, because we realized that even though we locally manufacture the wind turbine, the electronics are still bought off the shelf. And even though they're reliable, you know, when you go to the field and you need people to repair and you need people to sustain the technology, industrial mainstream technology just doesn't cut it, because you can't repair it most of the time. There's the measurement working group who has developed its own open source data logger. Go up. No, I can't. I think I lost. Oh, there you go. Who have developed a low-cost data logger, and we have some dev weeks on the past trying to find a way to bring down the cost of resource assessment within the network. We have the market assessment working group. I'll come back to it in a second. We have a PhD student from the Strathclyde University who just about to finish his global market assessment methodology. I'll give you some of his results. I think might interest a lot of you. We do have a maintenance manual that has been built together in a collaborative effort from different countries. And we have a delivery models manual for people to find a way to build their own delivery model, which is not necessarily a business model, it goes beyond. It has a lot of social engagement into it. So the best practices from the members who actually succeeded. We've participated in a bunch of international European projects. As a researcher, I like to travel, I like to do cool stuff. So on the left, we were in Athens running a few tests on the data logger with a small wind rig. On the center, we're doing the power converter tests. And on the right is a recent project that we did where we use the generic power converter to power a brushless synchronous and an asynchronous machine with the same hardware, just changing the software. Which is quite cool because it goes into the water pumping needs of the people within wind empowerment. Global market assessment. This is the result of a paper in 2017 from Alfred Alsop. The method, he's way much more expert than me on this. So the method is kind of explained on the left. You have the input, the processes, and the output. So your input, you have the solar wind resources, diesel price, accessibility maps, component costs, representative demand profiles, and you have the processes of filtering the outputs, and then they go into the market size filtering and give you a market assessment. He did a ranking of the top 15 countries in the world where small wind makes sense and which are the parts which drive that. And if you see wind is the blue on the bottom, it's not the prevailing thing. There's a little bit of solar. There is a lot about the country being safe, the terrain being appropriate, the regulatory conditions being right, the environment being correct, the demand being there, and so on. You can take a look at his work. You can find it on Wind Empowerment website, actually. It's in the Market Assessment Working Group subsection. You can guys go take a look, windempowerment.org. That's our website. He did some national assessments. He did one in Nepal, which was quite interesting, and Ethiopia as well, studying how the complementarity between wind and PV kind of drive the market and where can they be found. And some of the conclusions, I kind of like to join 2 presentations ago, the colleague who said that he was going to maybe be a little bit rough. There is simply no small wind market in developed countries. There's none. As an energy source, whatever is competing with the grid, it's very hard. In a developed country with a stable grid, it's very hard for wind empowerment, if not for wind, if not, oh, sorry, can you hear me? Yeah. Can you hear me? Is that okay? I saw you coming up.
Yes, we can hear you.
Okay, sorry. Okay. So one of the conclusions is there is no market for small wind in developed countries except in 2 places, where there's a very big complementarity with solar and you're off grid, like in the mountains, somewhere where really the grid cannot go. That's a sense to do that, but those places are very niche. Piggott himself lives in a small peninsula in Scorrig in Scotland, and in the 70s they had the chance of actually connecting the peninsula to the city through an underwater cable, and they chose not to. So they generate their own electricity locally, but they have a lot of wind in Scotland. But most countries, in developed countries, most of the places, there is simply nowhere to go. Now, there is a very big market for small wind in developed countries. I know this is hard to hear, but this is some of our conclusions. It's in education. Small wind is basically the holy grail of education because it's such a complex system that goes from aerodynamics to physics, through electromagnetics, through power electronics, control theory. You have everything into a single system. So aiming for the educational market, it's a quite safe bet when you're doing developed countries, because that's where there's a very big demand on having systems that people can actually build and deploy. That's what wind empowerment members in developed countries do. The most successful wind empowerment member in developed country by far is Tripalium, which is a big network in France. It's trained more than 2,000 people and built about 200 wind turbines, 100 of which are connected to the grid. So there's a big market in education in developed countries. In developing countries, there's a double P there. In developing countries, there is a market where PV and wind are complementary. Wind usually small wind comes into the optimization of a microgrid to reduce the size of the battery pack. If there's a complementarity between PV and wind, then it's an interesting solution. If there's no complementarity between them, then usually solar is going to win, and small wind is not going to prevail in that market. There are some cases in developed countries where people who are very off the grid and don't want to generate their own, they want to generate their own electricity. They have a lot of wind, a lot of solar, a lot of batteries, but they want to have a very small wind to get that like small energy amount that they need. I've seen that in some niche cases, but again, no big market for that. Energy access, which is what we deal with in wind development, is a social problem. This is a very important conclusion, and it needs a social solution. The way we do industry, it's a very asocial. We do not, our industry is not engaged into our societies. It's engaged in its own payback time. So our engagement with people is through a relationship of consumer or consumer, people want to flip the switch, it works. It's you give them the technology and so on. So energy access it's a social issue. And providing them with technology does not solve the issue at all. It's not a solution for the issue. Locally manufactured technology then can go where the industry cannot because it's cheaper. The upfront price is much cheaper. And usually it engages with the community because the community build their solution. So it's a good way to kind of black start the community into going through the energy process of expansion, and where the demand grows to the point where there's enough money locally and enough will politically to actually go to the industry to solve the problem. But there's just this threshold of risk and power that the industry cannot go below, and that's where local manufacturer has a sense. And this is the words of Alfred Alsop himself. I quote him on this, is the Piggott turbines are the right tool for the job, and engineers should actually appreciate it when it comes to energy access. Very quickly, my work, I work with open source power electronics. What does that mean? I try to be as brief as I can. That means that if we take a step back and we look at a power chart, current versus voltage, and we trace 50 amps, 100 volts, and those gives us a few quadrants, and we can actually place, people would, we can call that micro wind if you want. It should be less than 100 volts, less than 50 amps, because they're less than 5 kilowatts. I can agree with you on that, but that's where my small wind goes into. And everything that goes beyond 100 volts and 50 amps, I call that the grid, and you have, typical 350 volts and 800 volts for inverters and motor control pumps. And usually our wind turbines, they're located on this spectrum of power. So we have a lot of small wind between 200 and a kilowatt. They're located within the range of battery voltages. And then you have some big Piggott turbines, we call them big. For being locally manufactured, they're quite big. They go up to 3 kilowatt. And they're all somewhere up there, they're wound to be injected into the grid. There are a few solutions, battery chargers, locally manufactured charge controllers that kind of fit into that small niche there. And then you can kind of fill the sausage in the middle of the small DC motors, the inverters, 3 to 10 kilowatt solar inverters start to show up. And then you have the industry, some, industrial motors, big solar inverters, so on, show up later on a higher voltage spectrum. If we look at the power conversion, if wind turbine is going to do some AC to DC in our case, because we're directly injecting to the batteries, we do have DC to DC if we're charge controlling, if we are battery charging, or if we're handling PVs, and we're going to have some DC to AC. So when it comes to power electronics, people tend to do it like we did electronics in the 60s. That means that they associate a hardware to a function. In my work is to try to answer the question, how do I make a power processor? How do I do a software-defined power converter, the equivalent of a microprocessor in power, something that you can reprogram. It doesn't do everything. An 8-bit PIC does not do everything, but it does a lot of stuff within its limits. There are two ways of doing this. Very briefly, this is one way that a bunch of some of my colleagues in Grenoble, they do the equivalent of an FPGA. That means that they ignore the historical boundaries that have been set, the red lines that I traced before. And they kind of go for one module, and they put them in series in parallel, and that gives you the equivalent of an FPGA of power, something that you can reprogram, or an ASIC, where you can, basically it's a software designed power converter. You give them your power specification, they send you back a power converter in 2 weeks time that's working, and with the software and everything. So it's kind of like a service. It's very good. I can recommend them if you want. They're working on it. They've been working on it for 10 years. Maybe it will be operational in 10 years. They are starting to roll out their first prototypes in the market right now. And this is where we come in our project. We work with a different perspective. We're kind of to do a power processor. We found the small locus of low voltage modules that we're developing, some high voltage modules as well, and some sort of transformer module in the middle. And we can pile them up and put them in parallel to reach for higher ranges of power. Basic overview, we have a low side inverter that, we start at a very low power. You guys are going to laugh at this, which is fine. No worries. We start at 300 watts. We're starting to build a 10 kilowatt demonstrator, but that's in 2 years' time to proof of concept. We do have the low side inverter. We're working on the isolation transformer and the high side inverter. They're all 10 by 10 centimeter boards. And the idea is that you have these blocks. And if you're working within one locus of power, you don't need all of them. You can need only one, but they're compatible among themselves, and you can actually build a microgrid according to what you need. And we have a digital architecture that can send the data up. Actually, we kind of use the power converters as data loggers, so we can do what our colleague was saying a few presentations back, is to monitor the behavior of all the system. And that's where you can actually deploy in the F7 STM32 high complex algorithms, and you can kind of run the whole system. So observability is built into our design, and the idea is that we can unify power electronics around a standard hardware, an intuitive guided user interface, some open data monitoring, and unify the community. Very briefly, we are working, we hope to bring to skilled individuals the solution, to businesses and to the academia. We'll talk about it if you want. The idea is that you go to a website and you have the price tag on a power converter that is reconfigurable. So today you do have that, but with a power converter that is not reconfigurable. You have a function, you pay for that. But this is, you have hardware, you pay for it, and you can download for free the function from the internet. And we're gonna, this is our timeline. We're gonna ship out the V0 in a few months and V1 by the end of the summer. To do a very, very quick final leap here of faith, to kind of answer some of the questions that I heard before. This is a PhD student of mine trying to do some work on small microgrids and trying to do some systemic analysis. What makes a microgrid what it is, and how can we make it work and survive over time? And we focus a lot of energy balance. That's like a technical side. What's the kind of wind turbine? What kind of what kind of hardware do we put into the system? And some of the colleagues were saying there is some information balance, which means what kind of algorithm, what kind of measurements we're looking into, how do we automatically control this hardware? So I had a lot of interesting presentation about this, but there is a financial balance to be struck here, because you need to have productive uses so that people, at least in developing nations, where people actually get something out of the buck, and that can allow the local community to thrive with this new energy. Because that productive activity will actually fund the financial investment necessary to keep the energy balance running, keep the system, maintaining it. But if you can close the loop, like we said before, monitoring systems, that means that you can get data up to the financial balance part. It could be an algorithm, could be just something else, some people talking about it. And you can actually control through algorithm updates your information balance. But that's not enough. The loop seems to be closed, but there's something missing because there's a social balance to be found. This is where developing nations are different from us, is that there needs to be some sort of social investment and so social return from people on the system. If your social return is because you became a hippie and you want to be outside of the grid in a developed nation, that's great, but your social investment and your financial investment are going to be just overwhelming, and the system may not run. On the long term, you might not be able to handle it. But if you are a lot of people in a community isolated, like in the case of Piggott, there is a social investment of keeping that isolation, and there is a social return of having that autonomy, which is in their case. There's an information balance as well. That means that if you can have access to the data that's going on, you can actually have social control over what is happening and over the type of algorithms that we're using. And then you have to have some payment collection that goes back into salaries for some people. And that kind of closes the whole of the loop. We're working on this model. And the reason why I'm presenting these to you is that we consider in our project, we consider that Openness is a principle, and that's how you can attain a social balance. That's the lever missing on normal industry in developed nations. They cannot open their design. If they do, the risk is too great. And you have knowledge access. If you have access to knowledge and you have access to technology, you can actually act locally. You don't need to wait for some order from somewhere. And that's why all of our power converters in my project are all open source. The hardware, the documentation, the guided interface, the dataware, the whole thing is open source. It's a sandbox where people can develop technology and solve problems. And people can do that on their own licenses, but whatever's in the sandbox is for everybody. But Wind Empowerment also does only open source developments because they also believe in the same process. And and we all have a community space, a Discord channel, a GitLab, and a YouTube. You can access it. When you put the whole thing back together, at least in terms of power electronics, and this is kind of like the bet that I'm doing in my research, is that if you do have the open source hardware that is flexible enough, the open source digital architecture that allows you to get all the data, and the open source data architecture allows you to observe all the data and create your own algorithms for billing and adapting it to your local culture. And you have the community space where people can interact about the technology. Then that systemic vision can hold and you can make that system works on the long run. If you don't have that, I consider it to be hard, but that's still to be proven. Last few make people, have a less laugh. This is a small, 3 kilowatt system that we built a few, this was 2 years ago. We have, if you see on the left, there are, up here on the left, there are some silicon amorphous photovoltaic panels. This is actually a garden shed where we put some batteries. We did dig a hole so that in case of hydrogen is leaking, and we do have our power electronics inside. This is the tower of the wind turbine. Our Piggott turbine is here. We're raising the tower for a demonstration just in the place. There was, you see all the trees, there was no wind, but at least it looks good. It looked good for the people. And this is a typical system. You have the wind turbine that arrives here, and we can short circuit it for braking before the diode bridge. The batteries are on the bottom. And we do have 2 power converters here. We can't really see the second one, but one of the 2 was doing an MPPT. I programmed it to do an MPPT. And the other one is programmed to do, to connect the batteries, which are 24 volts, to the inverter, which is a Chinese normal, typical 12 to 230 volt inverter. So I can charge my cell phone. So this is an interesting type of experiment we're doing. Kind of proves the purpose of doing locally manufactured stuff. We can go back to that. You can ask me as much as you want about reliability. We can talk about it. And that's it. Thank you. The project that I was talking about is called OwnTech. You're more than welcome to ask about that. Wind Empowerment is the international association to which I'm affiliated, but also my laboratory in the CRS here. Have any questions, please fire them away. I'm happy to answer.
Thank you very much, Luiz. It has been very encouraging and challenging, in at least the conclusions or some of them. I'm sure not everybody will agree with you because talking about no market in developed countries, that might be right in urban areas, but there's a lot of areas within the developed countries as well where you still have a very big market. And I think Mike Berge just said what is actually available in the US. But anyhow, it has been very interesting. And I will now let it be open to the audience to bring in questions. And until questions might come in, I'll just make some comments because talking about small and medium wind. Small wind is normally for individuals. It is individuals who buy it and are self-consumers and self-prosumers. And talking about medium wind, it's normally small cooperatives with 5, 10, 20 people in villages and so on. And they're making some kind of a community power within these systems. And I still think there is a market for it. But I'm very interested in how can you make conclusions as you have saying that there's no market anymore?
again, thank you for the question. I wish Alfie was here so he can explain to you more in detail. What I understand, our understanding is that solar is so cheap, batteries are so cheap that wind has a very hard time surviving. And if there is no educational aspect to your wind business model, then it is dead in the water, because it's so hard to bring the kilowatt hour, the money per kilowatt hour down to what solar and batteries can do. Now, what's important here, I think this is quite important. If you want to build a 15 kilowatt wind turbine, how much is that compared to a 30 kilowatt solar system? Now, you see, we talk about the fact that it takes more land cover, that kind of stuff. Again, in comparable places, if there is enough solar, usually wind has a big disadvantage. If there is no solar, wind may have a fighting chance. But the problem of wind is that if you sell it from a normal perspective of having a reliable technology and not an educational purpose technology, your cost of having the certification of your turbine, having developed your product is so high that your payback for selling your turbine is so big that it's very hard for you to cut a profit when you're comparing, when you're fighting against PV. So what we say in wind empowerment, what we try to tell people is that the ideal scenario for wind is when it's complementary to PV, and when it's not competing to the source, but to the storage, because that's expensive still, even though in a few years probably it will be so much cheap that will probably nail the last nail in our coffin. But if when you're looking about storage, usually storage is expensive in the system. And the wind turbine can kind of help you bring that amount of storage down, because you can actually have a complementary source. So that's very useful in those situations.
But Luiz, you will also find situation where, at least here in the northern part of the world, where you see as more wind, as cold it is, and combine wind turbine with heat pump. That actually makes sense, and that means that your wind turbine can be, the payback time will be 6 or 7 years, and then it's actually very good. And so therefore, to exclude all this market, I find it a little bit odd, because you don't need to have this storage, as you said, and I think other speakers has been into it as well, that actually it is possible without storage. And of course, I agree that it's very good with solar, but going Arctic, I don't know if you heard the presentation earlier today by George Piggott about the Arctic areas and what to be done, because half the year you don't have any sun. So therefore you have to find some other solutions.
No, I mean, there are, if you want to talk about the niche, I mean, if we're looking into the, if we're pulling into strings and trying to find the few hundreds of thousands of euros markets laying around, I mean, we're talking about modern Western industry. Anything below a few million euros is not a market for us. I mean, I'm not talking about wind empowerment. Everything above a few hundred euros is a market for us. But the thing is, when you're building an industry, you're building a company, and you're creating technology, if you're looking into very niche solutions in very niche places, your cost, I mean, of course, you can always find a place where you can kind of squeeze wind turbines in. You always find them. Does that make a market? First question I would ask. And the second question is, okay, there might be a place somewhere for wind turbines in a few places, so on. Then why having a typical market where a lot of people are competing, trying to come up with a new wind turbine model, when we can actually collaborate with each other, create an open source, mid-range 10, 20, 30 kilowatt wind turbine that it can be easily locally manufactured in developed countries. Share the design it together. So we can build it locally and we share the design. That would definitely save the market, because then we would not have to compete in the design process. We would actually collaborate in the design process, bring that R&D down to the point where we can actually fight a good fight against the other sources. I mean, that's what I would say. That's what I think.
Yeah, but that sounds very good. And of course, it's also reasonable what you're saying, but you know, you can cook at home and you can go to restaurants. It's two different things. And if you go to the restaurant, you actually expect the food that you buy at a certain standard. But doing it at home, you can do whatever you want. And so it is with turbines as well. So therefore, but to make sure that you have products which are safe for people to have, you also need some standards, as we talked about before. And I really think that it's an issue which should be recognized. Also, the security for these homemade wind turbines. I think that people should have allowed to do it. Sure, I do, but it has to live up to a certain standard as long as there are other people coming in the near of it.
I would take any of you any time of day in a challenge for safety on the Piggott turbine. Piggott turbine is a design that has been battle hardened from the field. We have hundreds of people installing this stuff all over the world, maintaining it. I have a colleague that has redesigned the tower after his tower survived a monsoon, so he could help us better rewrite the guy wires calculation. Everything in a Piggott design, from the tower to the windings to the blades, the whole process has been reiterated by dozens of individuals from different universities. The Piggott turbine, even though it's a locally manufactured turbine, and you know it's not a perfect turbine, does not have the best efficiency. It's extremely robust, has been tested in different continents, and has survived a few hurricanes. When it comes to standards, you know, if you look at our assembly manual, if you look at the practices that we put together, it's very solid stuff. I mean, I can vouch for it with my eyes closed to build a few ones. Can you do certification on a small wind turbine as a Piggott style? I would probably think not, because the certification goes through a process where you have to certify the people who build and certify the building machines that do it, and you are in an alienation process where you put away the humanity on it, and you only think about how is this reproducible in 100,000 times. The Piggott turbine is a good balance between repairability and reliability. It is solid. I mean, again, I take the challenge. Anybody come up, show me your turbines, we'll show you ours. We know what its difficulties are. We do have challenges with the Piggott turbine. That's why we're working on the electronics, because we use diode bridges that make some noise, and the rectification with diodes make noise in the turbine. So we're working on the electronics and so on. But
I think in this forum, the Piggott is well-known stuff. We all know the Piggott. So
wonderful. Sorry.
So therefore, it's very good that you praise it. You're very welcome to do that. But sometimes, I'm having a feeling that you are talking as an urban person, and I live in the countryside or in rural areas or whatever. The reality for me is something else. What it is from a person who are not allowed to put up wind turbine in an urban place, because that's forbidden most places. So therefore, I think there's two segments. So I hope that in your conclusion, you can take the rural areas out of it.
Again, yes, I'm an urbanoid, unfortunately. I am also on the maintenance crew of my area. So I do go on the countryside in my region, and I repair the Piggott turbines that we have installed. We have a few pilots up here. The business model of small wind in France is that the small wind is built on doing courses, and it's put up, and we actually try to get as many people from the region as possible to participate in the course so that they can actually ensure maintenance.
Please speak louder.
Sorry. So let me just cut off the Bluetooth, I think. Can you hear me now? Better?
A little bit, yes.
All right. So I do the repair in the maintenance in wind turbines, Piggott turbines in the region. So I have some friends who live in the countryside and who put up the wind turbines because they wanted to be somehow independent. So there's a guy up in the hills from here, and we have to change his car hub, the car hub of his wind turbine. I forgot the name. Well, we have to repair his wind turbine every 6 months because it spins too much. It produces too much power. There are niche places. What I'm telling to people is not that wind turbine is not, I have to just move a little bit because I don't have a lot of internet connection always. I'm not saying that wind turbine of itself cannot solve problems. I'm saying that if you want to make a living out of wind turbines, your business model has to incorporate education if you're working on developed countries, because otherwise it's a very tough fight. You're facing a very long process of developing a technology, a very long payback. And even if you do find some niche places in some countries where you can couple it with other sources and so on, that means that your business model is constantly looking for places where you can fit your technology, squeeze it in, and you have a lot of costs associated with that. Whereas if you integrate education in your business model, that might give you a chance of making a better living out of it in developed countries again.
Yeah, well, thank you for your thoughts. I don't agree with you because I think it is wrong what you're saying, and all experience says it's wrong, even though it's a niche. Yes, it could be, but is it a niche when you're talking about pieces or a kilo or megawatt, terawatt, or what is it? Because I'm a little confused, I must say, about your conclusions. But I hope there are others who will go into the discussion here. Are there anybody who wish to?
Morten, I have a question for Luiz.
Sure.
Yes, please.
First, Luiz, let me assure you that we don't consider anyone working with the Piggott turbines and that technology snake oil. It's a very respectable group of people. You're doing good work, and we have a high regard. The snake oil we're talking about is we have turbines that are on the market in the U.S. that have an 860% efficiency, and that is a bit beyond what we think should be in the public square. So, but I just want to maybe reinforce what Morten is saying. Berge Wind Power has been at this for 40 years, and we have a fairly good track record. I avoid the education market because there's a very high cost of sales. There's a lot of hand-holding. We don't target that. It's a long project cycle. Funding is difficult to obtain, and so it's a difficult market. We take the orders we have hundreds of turbines at educational institutions, but we don't search them out. They come and find us. But I do totally agree with you that wind designing and experimenting with wind is a perfect educational opportunity to hit many fields that have to interact together to have a successful machine. And so that total agreement on that. And then finally, I just want to thank you for working in power electronics, because that is a critical function requirement, and we need much better electronics. We can't use the PV electronics so well, and I'll finally just point out that with your electronics, and the Piggott wind turbine is sort of like a Ferrari engine in a Chevrolet Vega. There's a little bit of a mismatch in the sophistication there, but thank you for what you're doing. I appreciate it.
Thank you. Thank you. That's a nice praise. I like that. Thank you. But, you know, again, I'm inspired by Piggott to do this. Power electronics is always complicated. That's the problem. Power electronics. Even if you want to do something simple, it's very complicated. So yes, we're doing something that sounds very complicated, but a wind turbine, even the biggest one, is very complicated if you look at it in the detail. Well, thank you. Again, I'm saying there is virtually no market. I can be wrong. I've been wrong before. So you guys, you know, I'm holding that. I mean, you guys been 40 years in the market. That means you have a product that has been turning for a long time. You have a lot of feedback. Your technology is mature. So you had a long process. If you've been 40 years in the market, you probably took off when the wind was taking off in the 80s. There were some historical reasons for which you actually could find the funding to kick off and to bring that technology up into speed and to fruition. My message here is that, again, if we look at wind as a normal market, I think it's a big chance that we're going to keep having people failing because it's so difficult of a market. But if we kind of federate efforts and build an industrial grade open source machine, we choosing the right open source licenses where, you know, people cannot just just steal your work away and close it, but actually that everybody has to collaborate. We might have a better chance federating efforts to collaborate and do sort of international collaboration in the design that brings the cost of design down. And that would give us that leeway of having, you know, more, you know, better chance of making a living out of small wind for people who are starting. You guys have been consolidating the market. Your product works. I think, I don't know. I would say that. Maybe I'm abusing myself. Maybe I say something wrong. Please correct me if I do. Well, I've seen a lot of wind turbines companies crash. Stuff that were very good technically was excellent. Some European companies, and they just crashed and burned because it is such a difficult thing to do. Yeah.
Thank you, Luiz. I've said before that we will try to make a follow-up today, and was not everybody who has a chance to ask Mike Berge and also to Dörde if she's still there. Dörde, okay, and also to, she's not online. Okay, pardon. And Niels Martin Jørgensen from Circle Energy. If there are any questions for the others, please raise them. There could, of course, be more questions to Luiz Villa. Well, Frits Ock from Holland or Netherlands, you have a question. Please.
Yes, I don't know if it's possible, Luiz, but the story of Karana Oliver in Ivory Coast last weekend on Euro Congress was very impressive. He builds very small Piggott turbines with people who only have $1 a day. Can you tell? I think for this audience, it's also a very interesting story. It's also let's say a niche market, but a huge niche market, because in Africa there are a lot of people who are living from $1 a day and don't have electricity. You understand? Yeah.
I thank you for your question. I'm really sorry. I haven't heard of him, of Oliver, that he's building small Piggots. I'll actually send a message to the board of Wind Empowerment right now to see if anybody knows him. Wind Empowerment has members in many continents. We do have a lot of people in South America. We have some people in Africa. Wind Empowerment is not, it's a federation of local stakeholders and local legal persons. So there are ONGs, there are universities, and there are small companies, and we try to, as much as we can, share best practices. That's why we had a manual and so on that I explained before. And the thing about small wind in developing countries is that, again, it's all that balance that I've shown you. It's educate, but in the process of actually empowerment, empowering people. That's where I think the Piggott design excels, is that it empowers the local stakeholders. And to a certain extent, I think that's why our industrial society has its own issues with planned obsolescence and stuff like that, because our industry does not really empower us anymore. It used to, but it doesn't. And I mean, at least not everywhere. Some countries maybe, but not everywhere. And the thing about bottom-up development is that you're kind of counting on the fact that the maintenance is going to have to be done locally. So when we do, sometimes wind empowerment does projects where members don't exist, like in Ethiopia, a project in Ethiopia where there were no members. We did it in the objective of creating a member in Ethiopia. Every time we go to the field, we don't go to the field. We actually try to talk to stakeholders in the field so they can create their own association or small company, whatever they want, and take on the flame of the Piggott technology and carry it into their country. In the case of Ethiopia, it didn't really work that well because the army has a hand on everything. The universities kind of didn't. In the end, it was political issues that kind of blocked it down. Yeah, I mean, it's not only about having a big market. There's a big need for empowerment in different places in the world, especially rural, in rural places in developing countries. Sure, again, there might be rural places in developed countries that need empowerment. That's great. I mean, that's why we have about, maybe 30 or 40 wind turbine courses only in France alone every year. Because people want to learn, they want to discover technology, they want to understand why they're here, and the technology goes a long way of giving people that, that satisfaction of knowing they can do things themselves. That said, there is a lot of space in the world to do locally manufactured activities. Small wind doesn't fit everywhere. Small wind goes, at least in our perspective, where it can be complementary to solar, because it is complicated technology. It is difficult to maintain it. So, again, I ask you, please go take a look at the global market assessment that we've done. If you're interested into market assessment in developing countries, join our conference. Next weekend is the market assessment team. It's going to work on Saturday. Is the presentation. Just go windempowerment.org, and there's a green banner, We Online 2020. Go in, register, watch the webinar. I think we can make a difference even in developed countries. I mean, I built wind turbines in Luxembourg. That's like the last place you need a wind turbine, right? But it did empower the local students. So, yeah. I know education, like you said, education is, our colleague said just before, is a complicated market, maybe in the US, because it's a privatized market. But in other countries where the state actually has a role to play and it does not deny its responsibilities, it can actually make a difference. We can make a difference as wind turbine manufacturers, I think. There, my answer.
We do have another a comment from Ignacio Cruz. Is that right? Yes, Ignacio,
Yes.
please come on.
Yes. Hello.
Hi.
Hello.
Good morning. Good evening. So I have a question, Luis. So
Sure.
We are working in the IEA frame, in the International Energy Agency, and we are trying to establish a group, a university group, just working on distributed wind, only distributed wind, in order to develop knowledge. The main aim is, as you mentioned earlier, just how to lower, if possible, if possible, how to lower the cost of the wind turbines, the different components, looking for knowledge, looking for downscaling, upscaling solutions to look for the trade-off solution on the different components of the small wind turbines, small and mid wind turbines. So in this way, we aim to establish a group, a university group, on these different blocks to get this objective. So what's your opinion about this kind of actions, international? This is a global action looking for in some ways similar to wind empowerment, but in the university frame, looking for new ideas, using all capacities, knowledge capacities, research capacities of universities. What's your opinion?
I'll make everybody laugh on this, but my opinion is join wind empowerment. Don't make a new, you know, for the joke, join wind empowerment. We've been doing that for a few years now. The National Technical University of Athens, we have a friend, a very good friend as a member of wind empowerment in the RURAG. He's done his PhD thesis on optimization of the Piggott Turbine modeling. He did open source modeling. You can actually find our website. It's an online open source actual flux machine modeling that he's made. He's been doing this for 8 years because, you know, it's Greece, things go, you know, yeah, crisis and all that. They had a hard time. I think it's interesting. Academia has a role to play. It's important. Usually, you know, I'm an academic as well, so I know that we all live in our ivory towers and kind of, you know, far off the reality of the field. That's why I do electrification, because it kind of grounds me a little bit in what's really important. That's why we're here. In Argentina, we have wind empowerment members, a local association who is like very, very close, a few months away or a few years away from actually making a clip and mount small wind turbine kit. So they're not very far. I'm not talking like very small. I mean, talking about, you know, 2 kilowatt wind turbines, very easy to assemble kit. So again, take a look at wind empowerment. We've been doing a lot of work on that. We welcome universities. We have a bunch already inside. But if if still that's not good, it's always a good thing. We would be glad to join that kind of initiative. We have plenty of field tests that you guys can try out with many of our members. And I mean, again, the Piggott design is very difficult to beat when it comes to optimization. But we do have, you know, we have members in Peru who cannot find a tree in 1,000 kilometers radius. So they have to come up with ways of doing carbon fiber blades, blades for the wind turbine. And we have some people in Sri Lanka who are doing exactly the same. So they're experimenting with blades, and the kind of technology they use to do their own blades is industrial grade technology. Basically, it's kind of handmade still, but the technology, the way they assemble it, the finesse of the work is very good. Again, I think it's that kind of initiative is always good. In terms of technology for wind turbines, I would recommend, again, when it comes to very small wind down below 3 kilowatts, I think the Piggott is a very good design. Maybe we could work on just to make it more industrializable. If we're talking about 5, 10, 15, 20, 30 kilowatt designs, you know, maybe we could all do an open source design. You know, there are open source licenses like the CERN license, you know, the particle accelerator. They made an open source license where it's basically an infinite, how do you call that? It's like a patent, but open. It's like an open patent where you make the design, you open it, all the plans, everything for people. And if they make any changes, they are obliged to open it to other people as well. So you have the guarantee of contribution. It wouldn't kill any of us to collaborate a few hours every week and try to make some medium range open source wind turbine that would be suitable for everybody. And then we can, you know, supply our own markets. There's a bunch of people from a lot of countries here, so we can supply our own markets, manufacturing locally, but we can design globally. And wind empowerment does not have the firepower to do 30 kilowatt wind turbines. We can't, not yet, maybe someday in the very distant future, but that's not our objective, not yet. So that's where I think that's a very important role for the industry to have, you know, let's make an open source, medium-sized wind turbine that we can actually transfer to universities. Universities can train people on this. And when they come out of the universities, they don't come out like they do today with their heads full of ideas and their hands empty because all the technology is closed. They come with their hands full because they can go into a market somewhere.
That's right. Thank you.
Yes. Are there any further questions? Just a moment. Well, anyhow, then I will say thank you very much for today. And it has been an interesting day. And I hope that most of you have got something out of it. We'll continue tomorrow morning at 9 o'clock again. And that will be with James Bradley from Australia coming on. So I think it's evening for him when he's on, anyhow. But and then we'll have some micro wind as well tomorrow. But I hope you all will have a good rest now, especially you, Mike, who might need it. So I want to say thank you for today, and I hope most of us meet tomorrow morning again. Thank you.
Thank you.
See you soon, guys. Bye. Thank you very much again for having us.
Bye-bye. Thank you.